Let's finish off areas between curves. Now here's a situation we haven't done. How do you find the area between two curves when the curves are given in the form not y equals a function of x, but x equals a function of y? Now when you draw graphs and they are written in the form x equals f of y, and that could be anything. That could be x equals y squared, and the other one could be x equals y plus 1, right? It could be anything, right? When you are given that kind of situation here, excuse me, the curves look like this, and the area between the two curves is left-right. You know how normally it's up and down? Now it's left and right. So how do you calculate the area? The good news is pretty much the same way you would have done before. Do you see that the x's now turn into y's, and the dx turns into a dy, and the y goes from c to d, so from small value to big value. Now, you have to know which one goes first and which one goes second. When you had functions that looked like that, wasn't the top one first, right? And the bottom one, that went second, right? That was kind of how you figured it out. When they look this way, then you got to figure out who goes first and who goes second. And the, oops, wrong color. The one on the right-hand side, right? The one that's furthest to right goes first. And the one that's on the left goes second. So that's how you tell. If you get it wrong, if you switch these and you put that one there and this one here, you'll know that you've done it wrong because your answer will be a negative number. It'll be -10 or something. So if you ever do one of these area between two curves and you get a negative area, then you'll look at that and you'll say, oh, I think I may have screwed up in the order, and you'll be able to fix it just by switching them. So let me show you one of those questions from the homework. Now it's kind of nice if they've drawn the thing because you can see it. It's quite hard very often to draw x equals y squared minus 4 and x equals e to the y. But I'm going to show you a bit of software that will help you for those questions where you don't get a picture. But since I've already got a picture, can you see it's already done for us? Can you see it's going from y equals -1 to y equals 1? And you see the red curve is called x equals e to the y. That's what that would look like. And the blue one, it's called x equals y squared minus 4. So off screen, I'm going to set up the formula for calculating the area of this function. Okay. Now, it's going to go from -1 to +1. So I've just written down the integral from -1 to +1. Okay. Which one do I write down first? Do I write e to the y or y squared minus 4? Which one do you write down first?
E to y.
Okay. Are we all comfortable with that's the guy to the right? And then you take away the y squared, take away 4, and the whole thing is dy. So I'm going to return now to our white screen where you can see all of that stuff. So you're comfortable with e to the y squared, all that good stuff. Are we good? Right, now, those brackets are important because is it not what it eventually becomes? If you don't put that little bracket, even if you do it in your mind and only write that, that's fine. But you do need that bracket because you're subtracting both bits. If you don't, a lot of people who make a mistake in this step, they go e to the y, take away y squared minus 4. Do you see that they get the -4 when it's take away and it should be a +4? Now at this point here, antiderivative, power rule, and add a y. Isn't that the same rules for all antiderivatives. They just happen to be using a y as a variable. And it's going to go from y equals -1 to y equals +1. If you plug in 1, you'll get e to the 1, take away a third, plus 4. If you plug in -1, you get e to the -1, that's -1 cubed, so it's -1, so you get a plus a third, and that is what, -4. Oh, excuse me, so what do I get? I get e, because that's what that is, take away a third, add a 4, take a 1 over e, because that's what that is, subtract a third, add a 4. And then that's 8, and that's 2/3. 8's 24, take away 2, I believe you get 22/3. And if you don't, you can pretend I calculated that correctly. And that's your answer. Are we comfortable about the process of finding the area between two curves, x equals f of y and x equals g of y? At least as a process, like in this question, right? We're good so far. Okay, now what can make this question a little bit trickier? Well, you might not be given a picture. So we're going to show you how you deal with that. And you might not be told a start and finish number. You might have to find where the two things intersect. Right, so that's an added issue as well. So let's see if I can. So let's suppose that I was given two curves, and it's going to be x squared take away 2y, and the other one's going to be x equals y take away y squared. And I've been asked to find the area between the two curves. Right, so this here is going to disappear in a few seconds. I don't have a sketch, so I don't know kind of what it looks like, and I don't even know where they intersect. So I'm going to show you how you can put this into a piece of software, and then we can proceed. So let's see what's going to happen. And the software I'm going to use is called Desmos. So if you've ever used Desmos, where are you, Desmos? Here we go. Are you looking at a Desmos screen? Right. So you go up here and you type in y squared take away 2y. And it looks like that. And then you do the other curve, which is x equals y take away y squared. You do that. And there, I'm just, you can't see what I'm doing, but I'm just using my mouse to scroll, zoom in essentially, right? Move it up a little bit. There. Now you can see the blue guy is x minus y squared. That's because it's got a little color code. Use that blue purple color means this guy. And the green one is y squared minus 2y. So I'm going to take a very rough version of that same question. God, this is a very rough version, but at least it gets the gist of it. Okay, now, so stage one would be get a sketch of the thing so you can visualize it. So you go to Desmos and you type it in. And that's what I mean. That's a pretty horrible looking thing, but it's kind of like the picture, right? It's just a visualization. Now, Step 2. Find not the x coordinates, but find the y coordinates of the points of intersection. Now, if you're really lucky, one of them, oh, by the way, the guy that we're trying to find the area is this thing, right? Can you see that that guy is pretty obvious 0, right? You can tell just looking at it. This is the other one up here, right? Not so sure about its value. Now, if you're really lucky, you can look at Desmos and read off the answer. In this case, it's 1.5, but of course, we don't like decimals in Calc 2, so we'll call it 3/2. But that's not always going to be the case. Can you imagine there might be a case where this y coordinate is √2 or 4/7 or something you couldn't easily read? So you need a backup plan. In fact, sometimes it's a good idea to read the answer and to do the math at the same time. So if I'm interested, where does this guy intersect with that guy, don't I just set them equal to each other and solve? Great. So let's see what that looks like. If you take the first curve and you make it equal to the second curve, if you add a y squared to both sides and you subtract a y from both sides, you get that. Okay, tell me what the next line should look like to solve this equation. What should I do here?
Quadratic formula?
Well, you know, the quadratic formula would work, so that's not the wrong thing to do. But I try and avoid the quadratic formula unless I can't help it. And, you know, occasionally you can't help it. So I can do something a little bit easier than that.
Yeah, 0 product formula.
Okay, so you pull out that guy, right? And that tells me that y equals 0, which I already knew. And can you see that y is 3/2, which is what we'd expect it to be. So step 1, draw a picture. Second stage, find the y coordinates of the point of intersection. Now, do you know step 1 and step 2 might not exist if you get a nice easy question where the picture is drawn and you know where to start and finish because they tell you. So these 2 steps might not even happen in quite a few questions. Now, step 3 is basically set up the integral. So I'm going to go from y equals 0 to, oops, almost did the same mistake, 3/2. Okay, one of these guys goes first, take away the other guy. So is it this green? No, it looks blue on my screen, but it's green actually. Is this one first or is this one first? Which one do I put down here?
Y minus y squared.
And you chose that one correctly because?
Oh, because it's the furthest right.
Yeah.
That's right.
It's the one to the right. Then you take away, and the second curve is the green one. Looks blue to you. And do you see I'm putting the little bracket thing around it again? So it's going to be the integral from 0 to 3/2 of y, take away y squared, take away y squared, add a 2y. It's going to be from 0 to 3/2. It looks like it's going to be 3y, take away y squared. Power rule, add 1 to the power, divide by the new power. Power rule, evaluated at 0 and evaluated at 3/2. And our area is going to equal ... Right, can't you just plug in the 3/2 here and here? That'll get you the first bit. Take away 0, tidy it up, make it look pretty, and I don't know the answer. You'll get 17/8 or 212/49 or some ugly fraction, but it'll be the answer, whatever it is. So I'll be comfortable about the process of how do you do the question when there's just a written question, no graphs, no pictures, no help, right?
Professor,
Yes.
with the when we're finding the integral for it's the third line. It says 3y minus y squared. Would that be 3y
Oh,
minus
2y
2y?
squared. It
And
would be.
then
Yeah. Well, I'm going to say the dot, dot, dot. Yeah. Just keep it. That's my usual. I can't count. But you know, all the best mathematicians can't count. No, that one didn't work. It's a tough crowd today. So far, so good. I'm saying what we need to complete here. Okay, I'm going to show you a partial question. All I mean by that is we're only going to look at some of what you need to do, not the whole process. So here it goes. In this question here, the two curves are called x equals 4y squared and x equals 4 plus 3y squared. Do you see those two? Now, there are 4 pictures here. One of these 4 is actually that guy, right? Now, it could be 1, 2, bottom left, bottom right, okay? Now, I would go into Desmos, I'd put them in and I could look at it and then I could easily pick it. But let's see if we can figure out what it might be just by visual clues. Why is this one here, the top right hand, a non-starter for this question? It can't be the right answer.
because it's in y equals x format.
Can you see the shape is vertical? It's a y equals x, just like Ripken has said. Now, for that same reason, can I also kill this one?
Yep.
Agreed? Now, there are 2 possible choices. It could be this one, and it could be that one, right? Now, unless you're really good, I think you're, well, unless there's an obvious thing that I can't see here. Well, there is a possibility. Couldn't I use the x-intercepts? Which makes it this one. I'm calling them x, I should call them y-intercepts. Where do these guys intersect on the y-coordinate values? Well, if you make this thing equal to this thing, do you know that y equals plus and minus 1? So that's why I'm picking that one. So I could get rid of 2 of them because of their shape. And the reason I'm picking this top one rather than the bottom one is that in this top one, I'm assuming that's 1 and that's -1. That's the guy that you've got. Now, Desmos is kind of indispensable. If you don't know Desmos, I'll try and remember, take a little note to myself here, to put it on Canvas, a link to it. And you basically sign up for it, but it doesn't cost you anything. And you can use it. Have some of you used Desmos in the past?
Yep.
Yeah.
Yeah.
Okay. So it's not, I believe so. It's that long since I joined it, I forgot. But I believe you sign up for it and then that's it. You're good to go. It's free. I guess that's what I'm asking.
I think you even have to sign up for it. It's just like a browser thing.
Okay. So it's a browser thing. The one I've got, you have to sign up for. So who knows? Maybe I got an indirect link to it. Who knows? But now when I click on it, I'm in. Okay, so what is left? Well, that's how you do examples where it's kind of left to right instead of up and down right. How you do questions that are in the format x equals a function of y. So I think to finish off with this section, what I need to do is give you some ugly ones to do. I'll be doing them with you. Of either form, it really doesn't matter. So I'm going to do y equals the tan of 5x and y equals, oops, the sine of 5x, but we're being asked to do it from here to here. Now this is good because this step says basically that I do not need to worry about where the start and finish values are because you're telling me that's basically your a to b. So I know the integral is going to go from a to b. Now I need to do tan of 5x and sine of 5x. So I'm going to do a little sketch to see what's going on. And the reason I'm going to do a little sketch is that, can you imagine it's just a big eye? In which case, don't I just need to know the top guy, take away the bottom, and I'm done? But if it's a crossover, won't I need to find the crossover value? Right. So let's see what that looks like. So if I type in tan of 5x, no, I want y equals clear. I'm going to do tan, where are you tan? Tan of 5x. And then after that, I'm going to do sine of 5x. So far, so good. Then I am going to do a window. And I know from here that it's negative pi divided by 15. And it goes to positive pi divided by 15. And then I'll just do a zoom 0, which should give me the picture. So that's the tan, I'm pretty sure. Ooh. Something's happening here, but I can't see it. So that's a bit annoying. So I'm going to zoom in. Oh, shooting space. I made a mistake. It's 2 sine 5x. Right, now I can do zoom 0. Should be fine. Oh, it may be still using the old window. It is, okay. So I'm going to go negative pi divided by 15, and I'm going to go positive pi divided by 15. Right, last time, zoom 0. Right, so that's the tan function. And oh dear, isn't it a crossover? Agreed? So let's make life easy. I don't know if you can see my mouse pointer, but I'm pointing at the origin. Do you see that? And won't this guy over here be positive pi 15? And won't this guy over here be negative pi 15? So let's try and make our workload a little bit easier. Looking at this shape, would you agree that this little leaf shape here is the same size as this leaf shape? So what I'm going to do then is I'm going to take the area and I'm going to say it's twice the integral from 0 to pi upon 15. Are you happy with me doing it that way? So I don't have to do two separate integrals. I can just do one and double the answer. Does that seem reasonable? Right, now, when you look at this shape, the top one is the 2 sine 5x. And the bottom one is the tan of 5x. So that's pretty much the integral setup now. From 0 to pi upon 15, doubled. Guy on the top, take away guy on the bottom. And as if that wasn't bad enough, we now have to integrate 2 sine 5x and the integration of tan 5x. I am going to do both of them totally separate from each other. So I'm going to do that guy. And then I'm going to do that guy, and then I can put them together. Right. Do you recognize that to integrate this, you need to do a U-sub? It's not a very ugly U-sub, but it is a U-sub. What U-sub should I choose to make this work?
$5x.
So du by dx is going to be 5. The du is 5 dx, and 1/5 du is dx. Now, if you didn't see that, isn't sine of ugly guy the reason I picked 5x, right? Sine of 5x, sine the ugly guy, make u the 5x. So this integral will now become 2 times the sine of u, 1/5 du. So this will become, probably don't need this line, but I'm doing overkill, that guy. Now, if you find the antiderivative of this guy, don't you get negative 2/5 cosine u? And that becomes negative 2/5 the cosine of 5x. So over here, I'm going to write down that guy. Now, let's do the second piece. It's going to be negative, this answer, but just to make my life easy, I'm going to do that guy, right? And then I'll make sure that I'll stick a negative in when I'm finished. Well, this guy is a problem. And there isn't a u-sub of 5x is going to help me. If I did a u-sub of 5x, do you know all I would end up with is 1/5 the tan of u, and I still don't know what the antiderivative of tan u is, unless I guess I'll go online and find out what the answer is because someone else has done it. So I'm going to do it from scratch. Do you recognize that a tan can be written as a sine over a cosine? That's the trick. That a tangent can be written as a sine over cosine. Now I'm going to choose my u-sub. I think there's really only one candidate. At least I know there's only one that works. What would be the suitable u-sub in this story?
Cosine 5x.
Think again.
Cosine.
Why will cosine of 5x be the better choice?
The derivative will cancel with sine.
Yes. Now you might say, well, won't the derivative of the sine cancel the cosine? Not really. The cosines will be in the same place as the thing you're cancelling, so you just end up with cos squareds. So it doesn't disappear on you. So in this case, you're differentiating with respect to x. So be careful. Differentiating a cosine is a negative sign. But isn't this a chain rule? So it's negative 5. Which now gives me negative 5 the sine of 5x dx. And if you isolate this whole thing, you can isolate that fella. So we now have the sine of 5x over u times, and this is the cool part, do you see it cancelling out? If you tried the other version, and you can do the working for it to convince yourself, but it doesn't cancel, right? You don't get rid of the cosines, you just end up with another one. Now, in this case then, that becomes negative 1 over u du, and isn't that negative the natural log of u, which is negative the natural log of the cosine of 5x. But it's meant to be the negative of that guy. So if I stick a negative, negative, negative all the way through, doesn't the answer become positive? The natural log of the cosine of 5x. And that was a lot of work. I'm going to dot that, because all you do is plug pi upon 15 in, and you'll end up finding the cosine of pi and the natural log of the cosine of pi. And then you plug in 0 and you'll get a similar result. And basically you're done. Now you see that one had the disadvantage of being quite an ugly question from start to finish, right? You weren't really given an awful lot to work with, and it certainly involved a fair amount of algebra and u-subs to get the answer. Right, so let me return back now, and we'll just do a quick scan through all the questions in the homework, and hopefully we'll have covered all the possibilities. So, I know. In question 1, you've got a little video you can watch, and they're doing the whole thing. It's very distracting for my brain to actually see it written this way. It's just too much there. It's almost better if you just ignore it and do it one step at a time. But it's taking through all the steps, and so is question 2 with the little video. So there are tutorial versions. Right, this one here we've basically covered, right? Would you agree this one here is pretty much good to go? You should be able to get straight into step 3. You don't need a picture. You don't need to find out where the start and finish is, right? You should just go straight into the integration. Would you agree this one is pretty much the same? Right, in this question number 4, the red or the blue? Who goes first in my integral? The red or the blue?
Red.
Right. Just remember, the one on the right goes first and you'll be fine. In this question here, it's 2 functions, 3 over x and 6 over x squared. So couldn't you probably put that into your calculator and see which one it is? If you're wondering what the heck this little rectangle is for, it's just to give you, I wish it was a square, but if you go vertical on it, it gives you an idea of top and bottom. So if I was doing this one, if it was this picture, wouldn't this straight line be first, you know, whatever it's x, darn it, I'm trying to think. Yeah, this is going up and down, right? So top function is the straight one, right? And bottom function is the curve. So whatever the straight line is, you write that 2x plus 1, and then you do the quadratic after that. That's much better. Now, you see this picture? Do you know the way it's written? Doesn't that mean that it's a left to right situation? Do those little rectangles kind of help me now? Can you see left to right rather than up to down? So it's going to be that picture there, or this one here, right? When you plug it into Desmos, hopefully you'll be able to tell which one it is. The nice thing is that you should be able to read off the two y values, so you know the start and finish. Top to bottom one again, left to right. That's the one we just finished a minute ago. Top to bottom again. Let's just pretend, just for a minute, that when you plug this guy in and this guy in, it was this picture here. Okay. Then wouldn't you do the integral from 0 to whatever that x value ends up being? And then from this value to that value would be my second one. And then from that value to the end would be the third one. So the end value I know is pi upon 2, but maybe that's a quarter pi, and that's whatever, 5/8. There's another up and down thing. Oh, if you want to find out where this guy intersects with that guy, the answer is it's a nice, easy number. When you do it in Desmos, you'll be able to read it off. If my memory serves me, I believe, oh, darn it, my memory doesn't serve me well. I think it's 0.5. I think it's this one. I think it's 0.5 and negative 0.5. Now, don't quote me on that, but I'm 90% sure that these two things intersect at that. So in this case, you're not really going to make this equal to that, because you can't really solve equations that are a mixture of trig and polynomials, right? There's no algebra that does that. But if you do Desmos, you should be able to find out where they meet. And I'm 99% sure it's this, what I think about it. I'll let you figure that one out. It's got an absolute value around it. And this should be, yes, it is. Question 13 should not have been there. I thought I'd taken it out. Never mind. The last question that you'll need to deal with is question 12. 13 will be missing as soon as I give time to go on and kill it. So what you've got here is red car A. This is its velocity curve. So you know at A and at 2 and at 3. And red car B is the blue one. Which car is ahead after 4 minutes? I don't know why that says A and 2A. When you're asking which car is ahead after 4 minutes, aren't you talking about which car has travelled the furthest distance? Now, it is possible to figure that out. Is it car A or car B?
Car B.
Which one's going fastest during that 4 seconds, A or B?
A.
A. And if you go faster than the other guy for 4 seconds, aren't you going to be ahead of the other guy after 4 seconds? Does that make sense? So I'm not doing math, I'm just thinking it through. Now, explain, won't the area under A, which is, forget B, but if you draw a vertical line downwards, won't the area under A, that big chunk, be more than the area under B? What is the meaning of the area of the shaded region? When you find the area under a velocity time curve, isn't that the distance traveled? Right, the area under a velocity time curve is the distance traveled. And the area of the shaded region is how much faster, it's the distance by which A is ahead of B. So if you're thinking, what's the area of that little shaded bit? That's how far ahead of B A is. And which car is ahead after 8 minutes, which is here. I don't know, is a short answer. So here's my guesstimate. Would you agree that this chunky area here is bigger or less than this one? So this chunky area here, is it bigger or less than this one?
Less than.
Okay, so that means he's going to do it. And it says estimate when you think the two. I don't know how to estimate, so I'm going to try and guesstimate. And my guesstimate is 9. And of course you get 3 guesses, so if 9 doesn't work, pick 10 and pick 11, and one of the two will work. And that is a good place. Will you say hi so I can take attendance? And that will be a good place for us to finish, because we've covered everything that we need to know. So I need to make sure that I get rid of that one question, which I thought I'd done, but I haven't. Any other questions? If not, we're good to go.
Yeah, I had a quick question about the last problem we just did.
Yes.
So it was on the last line, or the second to last line, it was sine of 5x over u times 1 over -5 sine of 5x.
All right, let me go and put that on the screen. Okay, so you're talking about what, this line here?
I think it was, or yeah. So and then it turns into 1 over ln of u. Where did the 5? Where did the 5 go?
That is a
sine?
very good question. It disappeared, didn't it?
Oh, okay.
You
Okay,
caught a
great.
mistake. We're good?
Yep. Thank you.
Right. You're welcome. Have a nice day, guys.